This is the Insurance Institute for Business and Home Safety's Disaster Discussions podcast, where we explore the intersection of weather and the built environment. As we wrap up another year of disaster discussions, we're taking a moment to look back at the conversations that shaped 2025. From wildfire resilience and severe weather preparedness to the latest research on building standards, this season brought together experts and stories that matter for safer communities. We're revisiting key insights, highlighting memorable moments, and celebrating the guests who helped make this year impactful. On January 7th and 8th, 2025, the Palisades and Eaton fires tragically became two of the most devastating conflagrations in California history, destroying a combined 16,000 structures in LA County. In the two-part February episode of Disaster Discussions, we're joined by Dr. Murray Morrison, IBHS Managing Director of Research, and Steve Hawks, Senior Director for Wildfire. Part 1 explores the extreme conditions that allowed these fires to transform into urban conflagrations, the damage investigation of the Eaton fire, and the importance of the working partnership between IBHS and CAL FIRE.
Our relationship with CAL FIRE, of course, is much more than that. IBHS really brings the scientific background where through our research that Murray leads and then our post-fire analysis like we did here on the Eaton and Palisades fires, we are able to determine the vulnerabilities with structures and then make meaningful recommendations on how to mitigate those vulnerabilities. And entities like CAL FIRE then take that information and are able to advance codes, in California's case, the California Building Code Chapter 7A and defensible space codes, as well as make improvements to their programs that they administer throughout the state of California, and then really target the funding that they have available to implement those programs on the ground. And so another example of that is we are working very closely with CAL FIRE on a structure separation experiment to better understand the relationship of structure to structure fire spread. And CAL FIRE is playing a critical role in that, providing some much needed funding to assist with that. And from that, we'll be able to provide guidance back to California on how they can make improvements to the California Building Code Chapter 7A. So it's really a relationship to take a coin from the sports world where we are much stronger together.
Part 2 covers the logistics of IBHS's post-event investigations, featuring the survey of Pacific Palisades, plus field insights that support scientific research back at the lab.
So talk about the role of garbage cans as connective fuels.
Yeah, they definitely are connective fuels. I'll say that. I mean, I think as we were talking about internally with people, I mean, I made the very, very kind of blunt statement. Garbage cans are taking out houses. Where we have these embers, you have a lot of fuel load in them. Embers are igniting these garbage cans. Typically, if they're kept outside, they're kept very close to the house, right up next to the house. And once they become ignited, we saw countless examples where even on homes that were undamaged, you saw the damage they caused to those structures, non-destroyed. So you could see the charring on, say, a stucco wall of where that garbage can had ignited. So they are absolutely a very, very large risk. It's something that we have to be mindful from a practical perspective, from a mitigation perspective, right? They're easily movable advice in terms of our objects, right? That you can move them out of the 0 to 5 foot zone, and you can easily move them right back in. So I think it points to some critical actions when red flag days are present to really move those garbage cans inside your garage.
In March, we were joined by Dr. Jeff Boughton, Adjunct Associate Professor at the James Cook University Cyclone Testing Station, and Dr. Cora Parakal, IBHS Research Engineer and Adjunct Senior Research Fellow at the James Cook University Cyclone Testing Station. This episode featured a discussion on Australia's Cyclone Tracy, a Category 4 cyclone that struck Darwin, Australia on Christmas Eve 1974, leaving 90% of the town's residential homes uninhabitable and tens of thousands of residents homeless. We discuss how Tracy's devastating impact sparked changes to the way Australia's housing was built and how these changes eventually led to a nationwide building code, making today's homes more resilient against high winds.
The resilience piece that Cora has mentioned is really, really important. As he rightly said, our building codes and standards preserve life safety. If we're thinking about community function, then for a community to function, the buildings have to be able to function. And so in order to keep buildings functioning after these kind of events, we need something more than just the basic life safety. We need Code Plus, we need Fortified, we need resilience built into our buildings, particularly our critical buildings, so that after it has happened, we can press the button and it's business as normal. Things like hospitals, schools, really important for those to have resilience. Even homes, if we want to have a workforce clocking in for work soon after the event, then their homes have to be safe. Their homes have to be functioning. And that's the core of the resilience piece. Resilience safeguards community function. So we need to broaden our thinking to how do we keep our communities functioning by keeping our building stock, our infrastructure functioning after these events have been through.
Right. Yeah, just to touch on that, Jeff, a saying I picked up on back at James Cook University is that you could say that there's no such thing as a natural disaster. There's either just bad weather, and then there's engineering structures or infrastructure that may or may not be up to the task. If our structures, our infrastructure, our communities are resilient enough, it is just bad weather. It's not a disaster. And you know, a big part of that is the importance of building regulations, even though it's perhaps the driest topic in the world, is instrumental. Building safe and economical houses that can weather storms is absolutely essential, right? Australia has been doing it for a long time. Florida is really good at it. We have the Fortified program as well. We know how to design a house to stand up to severe weather. These are not concrete bunkers. These are not concrete bunkers at all. These are light frame structures like any other, except they have the detailed engineering calculations performed, that tie-down chain that keeps the structure together. It's in many ways a triumph of engineering that we can keep these light frame structures together. We know how to do it, but it's really our building regulations that will really keep our communities safe. And so that's really the next wind engineer's dream of mine, is really that science communication, that advocacy that we do, both at the Cyclone testing station and here at IBHS, is to use the engineering, the hard yards that we put in already, and to just get that out there and get that entrenched and part of our communities.
In April, disaster discussions highlighted the development of the new Wildfire Prepared Neighborhood Technical Standard, the first and only science-based standard that aims to meaningfully reduce the probability of a built environment conflagration in the neighborhoods where it is applied. Dr. Ian Giamenko, IBHS Managing Director of Atmospheric Science, and Evan Sluter, Research Project Engineer, joined the podcast for a conversation on the science behind the standard's 4 core principles and how a wildfire-prepared neighborhood can act to slow the spread of fire throughout a community in conflagration situations.
Reasons why firefighting resources get stretched so thin on these fires is that initial exposure that these communities get. As wildfires enter a neighborhood, there's usually our 2 main components that we're considering. On the edge, there's that direct flame contact and radiant heat. And then as our fuels and the fire that's currently burning loft embers into the community, there's spot fire ignitions. So throughout the community where there are vulnerabilities, receptive fuel beds, we see multiple ignitions. So the fire service is kind of tasked with not only handling the fire front, where that actively burning fire is interacting with the edge of the community, but the spot fires that have ignited throughout the community. And in extreme fire weather, like we had with the Eaton fire and the Palisades fire, those spot fires rapidly develop and they can merge and turn into their own fire fronts and areas of conflagration throughout. So, and while also dealing with, ongoing evacuations and things of that nature, firefighters are really tasked with kind of this really challenging problem. So as we develop these passive systems, though, it prevents that multi-front scenario that they have to deal with. They can rely more on these passive systems that homeowners have implemented to prevent widespread ignitions throughout the communities, these spot fires that they have to go find and deal with, and they can focus more on the active fire front or where that fire is interacting with the community. So it's not that we will have more firefighting resources or anything like that, but the firefighting resources that we do have will be incredibly effective at managing, maybe those few ignitions that we get in the community when we have passive systems at work.
In May, research project scientist Jake Sorwert joined us for a discussion on why hail is an extreme loss driver across the United States and the reasons behind why that trend is growing. Plus, an in-depth conversation about lessons learned from a case study of significant hail that fell in Rock Hill, South Carolina, including key takeaways from the report, like how age plays a role in the performance of asphalt shingles at low to moderate hail severities. Plus, how using impact-resistant shingles can narrow the path of damage.
If we think about a hailstorm and a supercell thunderstorm, the largest hail is going to fall closest to that updraft. And then further from that updraft, you're going to have smaller hailstones. And smaller hailstones actually make up the bulk of the hail swaths from these supercell thunderstorms. And so if we think about this and we take it in a spatial sense and we take a cross section through that hail swath, right? Maybe you can't mitigate effectively with conventional asphalt shingle products in that largest hail. But if you were to go out further away from that updraft and towards those smaller hailstones, you start to see more of a spread in dependence on age. And so maybe a 5-year-old roof is 50% less likely than a 10-year-old roof to experience hail 4 kilometers from the updraft. Maybe your exposure is to 1-inch hail. If we increase the performance, so we put that excellent performing product according to the IBHS impact test standard on these roofs, and we just say, okay, across this whole swath, we're going to increase that baseline performance, then you're actually going to see a decrease in the amplitude of claim likelihood or claim probability in that largest hail. And you might eliminate the damage potential of those smaller hailstones too at those further distances from that hail swath.
And so of all the roofs you analyzed in Rock Hill that experienced this event, if they all had impact rated shingles, we know that with some of those bigger hailstones and the wind driven ones, maybe they likely still would have had a claim. But for those, not every home in this swath experienced the 2-inch stones, right? Some were an inch and a half, or even less than that. So those smaller stones, maybe they wouldn't have experienced a claim at all if they had impact rated shingles on the roofs. Is that what you're saying?
That's exactly right. And so really the idea is to raise the baseline performance and narrow the swath of damage from these hailstorms, right? And that's that's the goal in terms of hail mitigation. It's not necessarily to completely eradicate all damage, because if you get a 4-inch hailstone on your roof, you're going to have damage. Okay. If you get a 2-inch hailstone or a 1.5-inch hailstone on an excellent performing roof that's made to withstand 2-inch hailstones, the probability that you have damage is lower, and the probability that you completely eliminate damage from like 1-inch hailstones is high, right?
Yeah, so maybe your roof makes it through this storm fine, and maybe you don't need a roof replacement until the next storm or the storm after that. You get a little extra time out of your roof, which I think is what we would all like, both insurers and homeowners alike, right?
Of course, right. And this is how we start to bend down that loss curve.
6 weeks, 15 institutions, 4 international partners, and as many hailstorms as possible. That was the mission of the In Situ Collaborative Experiment for the Collection of Hail in the Plains, known as ICECHIP, that kicked off in Boulder, Colorado in mid-May. IBHS teams were there for the historic moment and spoke with some of the scientists involved at an open house event before the teams rolled out, including Central Michigan University's Dr. John Allen, who aimed to collect data that will further his studies on hail swaths.
So under a supercell thunderstorm, they're carrying vast amounts of water up into the atmosphere. As that water falls, some of it's falling as liquid precipitation, what we call rain. More of it is falling as hailstones, these balls of ice that are falling towards the surface. Now, a hail swath is constructed by the accumulation of hail over an area of perhaps 2 to 5 miles in width, of various different sizes. Now, some of that hail is going to be very large, some of it is going to be small, and then it can persist as the storm tracks across the landscape. So some of these hail swaths can extend for hundreds of miles. So it's a very wide array of area that is actually potentially impacted for hail, and it's very relevant to agriculture and the built environment. So one of the issues we have with hail observations is that we only really get the biggest stone, maybe the thing that happens to hit somebody who's present. So we really don't get a full representation of what is actually happening inside a hailstorm and what is actually hitting the ground. Now, translate this into the urban environment. If you have that falling over a populated area, certain houses are going to get damaged, others are not. So without that information about the swath, we really can't know how the hail is distributed, how its properties vary, how much damage is likely within an area, how we warn for certain areas over another area. Are we going to get really intense hail over a couple of 100 meters and then spread further or spread much further than that?
As hurricane season kicked off, Geotrek's Dr. Hurricane Hal Needham joined the podcast to discuss his 3-step process for disaster risk assessment, including the importance of knowing the deep disaster history of a location, identifying the possible risks in a particular neighborhood or region, and understanding how shifts from environmental changes can impact the potential for extreme weather, and how this knowledge can be used to empower communities to better understand their vulnerabilities to natural disasters.
Like, predicting the future is uncertain, right? Nobody knows exactly what's going to happen. But the idea, I think, is to try to educate and arm ourselves so much that the chance of being blindsided is really minimized, right? So if you know your deep disaster history going back to the late 1800s where you live, and you know what's happened in the region, you look to the east and west and north and south and get an idea of what's happened regionally, and then you're considering environmental changes to land use in the built environment and local climate changes as well. If you're well versed on this stuff, I think the chance of being blindsided is really reduced. It's never zero. We live in an uncertain world, and strange things happen all the time. But I think knowing these things and then doing what IBHS does so well is arming people like, okay, so even if you know your risk, what can you do to then mitigate that risk? How can you build better for wildfire? How can you build better for strong winds or flooding or hurricanes? And I think it's that combination of knowing the 3-step process, but then saying, okay, how do we take action on that? And again, checking out what IBHS is doing to build better for storms. You can actually take this information and put it into action to reduce the risk of loss for yourself and your community.
Every summer, IBHS welcomes a diverse and talented group of interns and fellows from across the country to work closely with our world-class engineers, scientists, and communications professionals. The scope of their projects is wide, assisting with full-scale research, developing state-of-the-art instrumentation and electrical solutions, running lab equipment to conduct research, designing and constructing building systems, and much more. Most of the participants are studying IT, engineering, meteorology, or communications in some form, spanning from undergraduates to postdocs. Some of these students even return to IBHS later in their careers. In this 2-part episode, we met these interns and fellows to learn more about their Summer of Science at IBHS, including engineering student Thomas Dixon, who told us that his time at IBHS inspired him to pursue his dream of working on a professional motorsports team.
It's kind of completely opposite direction that Craig's going. But I've always said that my dream job is somewhere in motorsports, specifically in motorsports logistics or team management. And so getting to work here and see, the 7 and 8 different departments all coming together between instrumentation, carpentry, fabrication, research, and everything else that kind of comes together. Getting to look a little bit on the project management side of things throughout my internship has really given me a good grasp and a good gauge of understanding just how better to mesh multiple different systems, which is a lot of the time what's happening in motorsports teams. You have your logistics guys, you have your mechanics, you have your electrical, you have your engineers, you have your researchers, and everything in between. So just kind of learning and seeing a lot of how the different things mesh. And as well as I talked about before, efficiencies, just trying to find the most efficient way to do things, the most cost-effective ways to do things. That's something that I got exposed to a little bit here this summer. And so kind of just seeing, like I was talking about earlier, just getting the most vast scope of things that I can learn within, a 10-week period of being here over the summer. I think that will definitely arm me and make me a better candidate than maybe somebody who did not have this internship or something of the sort going into future and hopefully a professional career in motorsport.
July was a busy month with the ICECHIP project wrapping up after 6 weeks of scientific storm chasing in pursuit of hail-producing thunderstorms. In this episode, we discuss the project's success in the field, highlight the valuable partnerships formed, and hear from research project scientist Brenna Meisenzahl about how some of the data collected on the project may be used.
What's also surprised me is we bring shingle panels out. We have been for the past 2 years or so. And it's been really cool to get the shingle panels that we have out here with us into some really large hail. We've been trying to do that for the past couple of years and haven't been successful, but we've got the F-Wave panels and a metal panel, and it's been really cool to see how the F-Wave actually does in large hail. Like, for example, yesterday we got 3-inch hail in the storm that passed over, and I think that F-Wave has experienced multiple severe hail storms, and it looks still brand spanking new, which is absolutely amazing. It gives us the actual real world results. Yes, we could do the testing at the lab, but this is where we're really going to see how that actually performs. We were cutting some shingles out this morning from that panel to see what it looks like on the back and if it was cracked or anything, and we don't see any signs of it. The sealant has been great. The shingle itself has been great. So it's really cool to see what we're doing in the lab and then bringing it out into the field and kind of helping advance the material science. I'm just in general excited to see how this is all going to come together and what these results are going to look like when we have our sounding data and our radar data versus what we're seeing on the ground. Kind of learning more that we're actually seeing more softer hailstones versus hard, which I know we do a lot of hard stone work at the lab. So I'm really interested to see how this is going to play out and how it's going to play out with our shingle ratings and how it's going to further advance what we're doing on the research side.
2025 marked 20 years since Hurricane Katrina devastated the Gulf Coast in August 2005, bringing wind and record storm surge to areas in Louisiana, Mississippi, and Alabama. Storm chaser Josh Morgerman, also known as ICECHIP, joined the podcast for a discussion about the record storm surge coastal Mississippi experienced during Katrina, sometimes referred to as the Forgotten Coast in the months after the storm. We also discussed the cultural and economic toll the storm caused and what the recovery looks like 2 decades later. Plus, Josh discusses his fortified gold hurricane house.
So I picked the land, which is 19 feet above sea level, and I'm like, all right, it's basically high enough to avoid the storm surge in anything but like a 500-year event. So in terms of water, I'm as good as I'm going to be if I want to live on the Gulf Coast. So then it became about building for the wind. Now, I'd never built a home before. I didn't know anything about this. And I'm so happy that I came upon the Fortified program because it gave me a level of assurance. You know, the thing about the Fortified program that I love is there's a third-party evaluator. There's someone who's looking at what you're doing, what your builder's doing, and is guiding you guys along the way to make sure that you're building to this Fortified standard, and helpfully making suggestions so that at the end you will hit that standard. And for me, that gave me tremendous peace of mind, just to know that an expert was evaluating what was happening, what was being built, and that it was meeting these sort of scientifically, these scientific standards. And that was very important to me to have that. So that was really good. It gave me real peace of mind. What I learned about mostly the thing, like the one term that I really came away with was continuous load path. The idea that a house is like a chain. And all of the, it's a bunch of links, and wherever that weak link is, that's where it's going to break. So no weak links. Everything's got to be super connected, from the foundation to the bottom plate, to the studs, to the top plate, to the rafters. And that was like the thing, that was like one of the big things I learned. And that's one of the important principles that my house really was sort of built according to, is that the connections across the board are really strong.
What happens when a storm meets smart construction choices? That was the theme for the September episode of Disaster Discussions. Mark Fowler from the Alabama Department of Insurance and Dr. Lawrence Powell from the University of Alabama Center for Risk and Insurance Research joined us to unpack a groundbreaking new report on IBHS fortified home construction performance during Hurricane Sally, a strong Category 2 storm that struck the highest concentration of fortified homes in the nation.
You know, what we learned, what we've been saying, true in empirical data now, fortified works. And that's what this whole thing boils down to, fortified works. And all the benefits that come from that. You heard that just in some of the largest presentation here about all the economic benefits and the collateral benefits that come in so many areas. There's less damage, means people can go to work. Less damage means kids can go to school. Less damage means the municipality has less to clean up. And it's all those kind of things. I heard someone say, a former EMA director here in Alabama, say a present employee or prepared employee is a present employee, is how he said it. That means if you're prepared and when the storm comes because you fortified, you can go to work, because more than likely you're not going to have the damage that would mean you'd have to be displaced. And so we, with this report, we now have real live, a true scientific report, empirical data to back up all that we've been saying all this time. And we couldn't be more pleased with how it came out.
Earlier this year, KB Homes' Dixon Trail development in Escondido, California, became the first neighborhood in the country to receive a provisional wildfire-prepared neighborhood designation, with every home in the development constructed to the Wildfire Prepared Home Plus level, IBHS's most rigorous wildfire resilience standard. KB Homes president and regional general manager Steve Ruffner joined us in October to discuss KB Homes' forward-looking commitment to wildfire-resilient construction.
Our company, the customer comes first, and just knowing that they're so pleased. And also, it's been a great experience. We have toured many municipalities. We've had all the fire marshals from the state through. And what we want to really tell them is this 5-foot, I call it safety zone around the house, doesn't mean that you don't landscape. Like it doesn't mean that the house is going to look bad from a street appearance or the elevation's not going to look good. And so we're able to demonstrate that with our models, and they're able to see the community. And I think everyone now realizes that this is viable. You can do it, and you can still have a really nice looking yard and protect yourself from wildfire.
In November, Disaster Discussions hosted scientists from UC Berkeley, our research partners and collaborators for the wind-driven building-to-building fire spread experiment. In this 2-part episode, we explore the growing threat of WUI fires, events where wildfires invade suburban communities, turning homes into fuel and escalating into catastrophic conflagrations. The first episode highlights groundbreaking research from UC Berkeley using real-world data and advanced modeling to better predict and mitigate urban wildfire disasters. It features Dr. Michael Gollner and Dr. Wukwan Sui of UC Berkeley.
I think this is a great, sort of as an example of how groups can work together to bring big science and make it happen. But I also think that we're still in that, these are disasters, and we're still in that scenario where we have a very difficult challenge to get all these mitigation things we're learning onto the ground. And I think a lot of it comes down to trust. People in communities need to trust that the data that we're creating is accurate and that it's going to work. And so this is one step demonstrating it. And the universities, we're going to do our research and independently verify things. National labs are going to do their work. And then companies are going to have to actually include those things. And it's this whole sort of nexus that everyone has to work together. And that's the essence of the wildfire problem. Mitigations have to happen a lot on private property in people's homes, and it's really difficult. And we see these challenges now with new laws and regulations coming up in California. There's a lot of challenges in getting them in. And so the more science, the more facts that we can add, and the more groups involved in putting these out and verifying these, I think that's really going to help push mitigations to the ground and reduce these fire disasters.
The second episode examines the hidden dangers of these fires beyond property loss, focusing on new CARB-funded research that quantifies toxic emissions released when homes burn. Together, these conversations reveal how science is reshaping our understanding of fire behavior, air quality, and public health in an area of increasing wildfire risk. Guests include Dr. Nathan Kreisberg of Aerosol Dynamics, Inc., and Dr. Alan Goldstein and Michael Malazzo of UC Berkeley.
There's been a lot of work, particularly out in the Western United States, at reducing air pollution, and California has had a major focus on this. But it's true across the country that air pollution is much lower than it was in the 1970s and 80s. And when we look at current air quality regulation, one of the things that is the biggest problem is PM 2.5. And in the Western United States now, if you look at exceedances for PM 2.5, it's almost all due to wildfires at this point, at least in the San Francisco Bay Area, but through much of the Western US. And so understanding the emissions from these wildfires and the contribution from structures within the wildland-urban interface is really important for solving what is today one of our biggest air pollution problems. And I think that the public will be very interested in these results, as will the regulatory agencies. And some of that particulate matter and other chemicals does get into soil, it gets into water. And so it's many of the same chemicals actually that are emitted into the air as get into the water and soil that can linger and have a longer term effect. The air is actually transported away fairly quickly. So within a few days, smoke typically clears from an area after a fire, but the residual that's left in the soil, that's left in the water, persists for much longer.
To close out 2025, we journeyed to the heart of Tornado Alley, to Oklahoma, where tornadoes and hailstorms are a way of life and homeowners face some of the highest insurance rates in the nation. Fortified contractor Scott McCollum Sr. of McRoofing.us joined us for discussion on how the Fortified Roof Program and the Strengthen Oklahoma Homes initiative are transforming resilience in Oklahoma.
It's the same thought over and over again is let's just collaborate. Let's get everyone together. Let's get our carriers and our legislators and regulators. Let's get everybody in the middle. That's the adjusting community and the contracting community. And let's get the consumers and let's all get on the same page. If we will work together, apply common sense solutions to the issue that we have right now, again, we can't make the severe convective storms go away, but we can mitigate risk, we can save lives, we can protect property, and we can all have a brighter tomorrow.
To our guests this season, thank you for lending your voices, your research, and your stories to Disaster Discussions. Together, we've explored the science behind resilience and the steps we can all take to reduce risk. Your contributions have sparked important conversations and inspired action toward a more disaster-ready future with solutions that make communities safer and more resilient. Thanks for listening to the Disaster Discussions podcast. Join us next month for a new episode. For more on IBHS's ongoing research efforts, visit IBHS.org.